Hey, good morning, good afternoon, good evening, whatever time it might be where you are out there. Welcome into this session. This is part of Codegen 2021, part of CloudGen Verona. Thank you so much for having me. My name is Jeff Fritz. I'm a principal program manager from Microsoft, and we're going to be talking about Blazor, building next generation web user interface. How you doing there, chat room? It's so good to see you. We have a live chat room going on here right on YouTube. Check it out. It's going to be right over here, maybe just below if you're watching on your phone or your mobile device. I encourage you, drop in there, drop some questions along the way as I'm going along. I'll pause and answer them, and I'll even have some time at the end that I'll answer your questions about Blazor and building next generation web user interfaces. Now, I do know there's been a number of other sessions as part of this event talking about Blazor, but for those of you who didn't attend those sessions, who want to know a little bit about getting started with Blazor, I want to show you why you might choose Blazor for your next application, some of the cool things that you can do with Blazor, and why you can build some really amazing applications using Blazor and my favorite cloud service, Azure. Let's take a look. Let's get into this and take a look at some of the slides and learn a little bit more about Blazor and web user interface with WebAssembly. Let's talk about this. I'm seeing a bunch of folks come here into the chat room. Welcome in. Hello, Mike in 2022, Marco D'Angelo, Andrea Dung. Good to see you. Thank you so much for chiming in there. So let's talk a little bit about where Blazor came from, where it's going to. But first, a little bit about me. There I am. Jeffrey T. Fritz, that's me over there with that fantastic Blazor. See what I did there? It's a Blazor, and we're never mind. You can reach me on Twitter. I am C#Fritz. On GitHub, I am C#Fritz. And if you want to find me on the LinkedIn, you can find me out there. I am Jeffrey T. Fritz. And like I mentioned, I'm a principal program manager at Microsoft on the .NET team, talking about helping folks at various virtual events, building virtual events, and getting those started, and getting folks engaged with some of the cool .NET technologies that we have available. So this is Codegen 2021, and you can find out more about the event at CloudGen_Verona on the Twitters. Make sure you check them out. Give them a follow. There's going to be some great events coming up in the future. We want to make sure we want to support our friends that help put on this event. So Microsoft and JetBrains, big sponsors for the event. Big thanks to them for helping out assembling and putting this on, whether it's through Teams, YouTube here, all the support to those folks. Thank you so much. So let's talk about WebAssembly. Let's talk about this new thing, WebAssembly. What is this? Why do I want to use this? What's going on in my browser, this WebAssembly thing? That sounds really complicated. What are we talking about here? So WebAssembly, abbreviated WASM, W-A-S-M, is a binary instruction format for a stack-based virtual machine. WASM is designed as a portable compilation target for programming languages, enabling deployment on the web for client and server applications. And this comes from webassembly.org. You can find that definition out on their website. So what does this mean? This means that you can compile your application as a binary, right? You might see it as an exe, right, or an executable file on Mac or Linux. You can compile your application as a binary and run it in the browser, because we're going to have this cross-device, cross-operating system compatible virtual machine that we can run your application on top of. It's going to be compatible regardless of the browser used, because everybody is going to support the same WebAssembly runtime. Okay, that sounds impressive. That sounds interesting. Jeff, tell me a little bit more. WebAssembly is designed to be efficient and fast. So the WebAssembly stack, it's designed to be encoded in size, load time, efficiency binary format. We want you to be able to get your application, your executables, loaded into the browser quickly and efficiently. So it runs quickly, and everybody can have a great experience running your application. We want to make sure that those WebAssembly applications are safe. Run in that same memory-safe, sandboxed execution environment that our JavaScript applications run in. We're going to enforce same origin and permission policies of the browser. We know how to do this. We've been building with JavaScript for some time, so this isn't too far off the mark. Okay, Makes sense. If we're going to deploy applications in some other format, these are things we want to have in our applications. Let's integrate with the features we already know. So let's let WebAssembly cross the bridge and interact with JavaScript context and browser functionality using the same web APIs. If we already know how to do that, if they're already there in the browser, we can lower the on-ramp. We can make it easier for folks to adapt and use WebAssembly with their existing applications if they can communicate with the same APIs. Terrific. And let's also make sure WebAssembly is part of the open web platform. Let's make it available through this versionless, feature-tested, and backwards compatible nature of the web. The number of times that I see people try to use the blink tag still out there on the web, it's true. Folks try to use that. Sometimes the browsers accept it and work with it. Sometimes they don't. But table tags, all the things from HTML1 are still available out there, and folks can still use it. Well, now that WebAssembly is part of the HTML specification, it's always there. It's part of the open web platform, and you're always going to be able to interact and use it. Now, do you remember these things? Spectre and Meltdown. There you go. You can see the icons over here. These were vulnerabilities in modern processors that allowed programs to steal data as it was being processed. Right? Wasn't that a pain in the neck? And everybody who had a modern processor on their machine had to patch their browsers and operating systems. So even JavaScript in the browser could activate these exploits. So since everybody had to patch their browsers, we know that at a minimum, everybody's got a browser from 2017. And WebAssembly was made available before 2017. So we know that everybody has a browser that supports WebAssembly. That's pretty good. All right, I'm feeling good about that. So I don't have to worry about compatibility and somebody running Internet Explorer 5 out there and saying, oh gosh, I can't use WebAssembly because it's not in my browser. You can't use Internet Explorer 5 anyway, or else you're going to be hacked by one of these things. So okay, we're pretty safe. We've got a usable surface area that we can go into and work with. But why use WebAssembly and not JavaScript? Well, WebAssembly can be natively decoded much faster than JavaScript can be parsed. And there's experiments that are available showing 20 times faster for WebAssembly to execute in the browser. And WebAssembly can be targeted by many different programming languages and frameworks, not just JavaScript, right? We can bring our favorite programming languages into WebAssembly, and that means all developers get to write code in the browser using their favorite languages. More information about that at webassembly.org. Now, these are some of the very cool WebAssembly languages that you can use to build, some of the programming languages you can use to build targeting WebAssembly today. .NET, AssemblyScript, look at the C languages, Clean, COBOL. Yes, you can use COBOL. You can use COBOL so much I put it on the slide twice. Okay, it was a mistake, but it's there twice, just in case. But I mean, Rust, Ruby, Lua, TypeScript is over there, Python, Lobster. I've never used Lobster. Lobster is a programming language. It's not just a delightful dinner. That's right. You can use Lobster. Kotlin, of course, PHP, all these programming languages. It's not just one or two that you can use here to build and target with WebAssembly. And there's a list of awesome WebAssembly languages here that you can go to and check that out. Now, let's take a look at some demos of really showing WebAssembly at work in the browser. And I'm going to be using Firefox as my browser of choice here. But these demos work in your favorite browser, whether it's Google Chrome, it's Microsoft Edge, it's Apple Safari, your choice. It works in all of those places and on your favorite mobile device, your phone, your tablet, what have you. Let me head over to a browser and let me show you some of these demos that I think you're going to find a little bit interesting. So let's look at this first one. We've got these characters walking here, and this is written in JavaScript, this demo. So let me zoom in just a little bit so you can see up here. I have a frame rate being shown, and I've also got JavaScript, and I'm showing 8 characters, 8 figures walking through here, and these are 3D rendered characters in JavaScript. And if I just take this and we increase the number here, let's go up and bring it to, let's say, 90 something, right? You see, this is struggling, right? This isn't a frame rate, I'm sorry. This is the animation that it's going through, the number of frames it's trying to animate. And you can see we're starting to stutter here. But this is with JavaScript. It's parsing and interpreting and painting the screen here. In fact, let me hop off the screen so you can see some of these folks. Look at this. Look at this. If I change this over to WebAssembly, everything is smooth. We're now using programming languages that are more appropriate for painting and animating 3D characters on a web canvas. This is all being presented to you live in the browser. In fact, I'm going to grab this link here and chat room. I'm going to drop it there right in chat. If you want to click through in another browser on your machine, or you want to bring that up on your phone or whatever, go ahead and take a look. Hey, where'd all my dancing figures go here? They've wandered off on me. Refresh that, and you'll see, right? If I grab this and I just move the mouse up to increase it, and they, with WebAssembly, come through very smooth, and then they start dancing, and my pressure to render here is very low. But if I take it over to JavaScript, I'm pushing through so many more instructions, and it starts to drag here. It's not fluid. Now, okay, you know, this is great. You're animating little 3D figures here, Jeff. That's so what? That doesn't impress me. Well, what if we put an entire Game Boy emulator, the Nintendo Game Boy? Remember the little handheld game playing device, right? Game console. Well, I'll just choose one of these open source games, and we can load it up, and we can play an entire Nintendo Game Boy game right in the browser. Okay, but you know what? The Game Boy isn't that impressive. I mean, it's black and white. Eventually they got to color. I mean, that's not that impressive. I mean, come on. Really? Fritz, what are you showing me here? Come on. All right. How about Diablo? So this is WebAssembly Diablo. This was a game that was released in the late 90s. A shareware version was made available, and we can load this up and play this in the browser completely. Okay. There it is. Look at the animation. It's really good. I can jump in here. Sure, I'll play as me. And we're back in Tristram, wandering around. Now, who's this guy? No, you, right there.
Hello, my friend.
Oh, yes.
Stay a while and listen.
It's Deckard Cain in the browser. Think about this as a deployment platform. Being able to run full executable applications in the browser. That's pretty good, right? And now this is just the shareware version. I've loaded it up, and of course, it needs to download chunks of the binary for us to show here. I mean, okay, once again, this is a game from the 90s. We're not doing anything too sophisticated with the graphics or anything here. How about Doom 3? Do you like Doom 3? If I start this up running here in the browser, it's got to load the data, but this is WebAssembly running in the browser, and it's running a full version of Doom 3. Now, Doom 3 from the early 2000s, this game's, what, a little bit more than 10 years old? But they've ported it and launched it so that you can play it in the browser. That means it runs on every device, right? That Diablo demo, oh, I didn't share the link to it. That Diablo demo, if I just reopen that real quick, and I'll copy the link while this is starting. There it is. You have the link in chat if you want to go and check that out as well. So this is going to have Doom playing in my browser once it finishes loading. Now, of course, this is a pretty big game, and you see how many frames per second are being presented here. That's pretty good. And we're about to get the sound coming through and everything, right? Come on, where's my sound? I had sound for this. There was sound. Oh, I muted it up top. Hang on.
Weapon and defense contracts. New ventures have expanded into biological research.
I'll let this go for just a second to get into the game, but what I want you to see is there's a lot of power here in the browser that you have access to as a programmer on every device, every operating system. Yeah. Come on with the story. I want to get into the game. I want to shoot things. Come on now. Make with the snappy. Here we go. So, I'll leave it to you to go and visit and play through the demo here. It's taken a little bit longer to get started than I expected, but the fidelity here is amazing. The frame rate, better than 60 frames a second. So, you're going to have a good time checking this out and playing it in whatever browser. And you can maximize this and all that stuff. So, that's pretty cool. That's a lot we can do with WebAssembly in the browser. So for me, as a .NET developer, I want access to this kind of power. I want to be able to publish and do those kinds of things. So that's where Blazor comes in. Now, about 5 years ago, we had this concept of, well, gosh, if we're working in the browser, we being the .NET team, that is, if we're working in the browser and we're making requests to some server that's living in a nice fluffy cloud over here, and maybe it's your favorite blue cloud maybe it's a nice shade of blue, a nice Azure color. You're typically making requests from your browser over to the cloud server. It's rendering some data on the server and pushes it back, and it paints in the browser. Well, we like to think that .NET developers, you want to run your .NET over here in the cloud. You want to run it on the server, and it's going to render your data and send it back to the browser. And maybe in the browser, you're going to use one of your favorite JavaScript frameworks. Whether it's just plain old JavaScript, you're going to use Angular, React, Vue, one of those frameworks. That's great to react and to that data, to that interaction, and paint and update the browser. Well, that's nice. But once again, I'm in JavaScript. There might be a better way to do this, and I want to get access to that WebAssembly power. So that's where Blazor comes in. So you can run Blazor in the browser, and it'll make requests to the server instead. So our Blazor applications, we can build client-side web user interface with .NET instead of JavaScript. We can write reusable web components with C# and Razor. So where you might have directives in Angular and components in React that you're referencing and pushing around, we can do that with C# and Razor. If you're a .NET developer, that's pretty familiar to you. Share .NET code with both the client and the server. We know how to do this with technologies like .NET Standard, where we can lift and share logic, share business logic between various .NET programming, .NET frameworks and user interface driven applications, whether it's Windows Forms, WPF, ASP.NET, well now Blazor. You can share class libraries and logic across all of them. And because WebAssembly provides it, we can call into JavaScript libraries and browser APIs as needed. All right, now we're talking. Now we don't have to throw the baby out with the bathwater here. We can use a little bit of JavaScript with our Blazor application so that we cross the boundaries and use a little bit of both as we go and migrate applications to use Blazor. So you can also run Blazor on the client or the server. Now, Blazor Web Assembly, I mentioned, this runs in the browser, and it runs on top of something called Razor components. That's the components that we make available to you to use in a Blazor application. Well, those components compile and run on top of .NET, and that version of .NET, that .NET runtime, sits on top of WebAssembly. So we got this nice stack that is very clearly defined, and all the items in that stack interact with the DOM, the browser's document object model, so that we can have nice interaction. We can make requests and update the browser and the elements appropriately. But we've also got the ability to run Blazor on the server. So what happens here is, and let me hide my camera here. You can make requests that come from the browser as folks interact with the DOM, and interact and send requests over to the server, where we'll take that same Blazor stack and have it run those Razor components on top of .NET inside of an ASP.NET Core application on the server. So we've just changed where that runtime lives. Instead of the runtime connecting to and interacting with WebAssembly, it interacts with ASP.NET Core. And to make sure that we update the browser nice and snappy, nice and quickly, so that folks get that real-time interaction, we're going to bring in SignalR. SignalR is our .NET abstraction layer over top of those live communication techniques like WebSockets that you would use to connect and communicate between two servers or two applications running on the internet. So we'll use SignalR to push updates back to the browser as changes happen with the application, and the server raises those events. So what you should know is that these application models became available in .NET Core 3.0 for Blazor Server, right here. And in .NET Core 3.1, Blazor Web Assembly became available. Now, it was just after .NET Core 3.1 is when Blazor Web Assembly became available. What you can take comfort in knowing is these are both available and work in .NET 5, the latest version of .NET that was released in November 2020. So, it's available and we can use this wherever we'd like. Now, there's advantages to both of these. You're going to choose Blazor Web Assembly if you want offline support, if you want to build a progressive web app, So you want that application that's going to be installable on a mobile device, has no latency in the user interface. You can click around and all the interactions that happen on the device happen very quickly right there. And we can do static site hosting. More on that in a bit. Blazor Server, though, is great if you want a thin client. You want to deliver just the HTML, just the things needed to render the web page. If you need access to a full runtime and you want to have all of your code running on the server, you don't want to share any code, you don't want to publish code out there so that folks can access and interact with it. Maybe you have some sort of a verified system. You have some interactions where you need to make sure that nobody can touch the code, touch the application that's running this. You can do that with Blazor Server because all of your business logic lives on the server. Very good stuff. So you can get started with Blazor. It's real easy. Go to blazor.net and you can download the .NET 3.1 SDK for Windows, Mac, or Linux. Or later, you can download the .NET 5 SDK as well. And you can start a new Blazor Web Assembly application with these two commands at the command line. .NET new Blazor WASM and .NET run. And you're going to get a nice little templated application that you can interact with. So let's do that. Let's start the first application. Let's see what that looks like. And let's also take a look at the Blazing Pizza workshop. This is a workshop that the .NET team makes available to you that you can go through and learn all the different features about building a Blazor application with a fictitious pizza parlor that interacts and sends out. Folks can place orders for pizza and have orders delivered to them, but it's a sample app, something we can take a look at. Links to the Blazing Pizza workshop are available here, github.com/.net-presentations/blazor-workshop. All right, let me head over to a console here, and we can start writing our first .NET Blazor application. So I mentioned everything runs at the .NET command line here. So if I say .NET new, you're going to see all the templates that come with .NET 5 right there. I have .NET 5 installed on my machine because it's the latest and greatest, and I don't want to be left. I don't want to be using something that's not the latest and most recently available. So I'm going to start a Blazor Web Assembly application. It's right here. Let's do that. Let's create a new .NET new Blazor WASM. And I'm going to specify an output folder here, and I will call it Codegen 2021. And it's going to create that template. It's going to drop it into a folder called Codegen 2021. It's going to run restore, and it's going to restore all the packages to this, just like if the packages might be coming from pip, might be coming from npm. For us in the .NET world, they come out of something called NuGet.org. All right, so let's open this in my Visual Studio Code editor. Everybody likes Visual Studio Code, so let's open this up and we can take a look at what this looks like and see what makes sense here. See if what's inside this application and kind of navigate around and see what's going on. I've got a project file here that's really the manifest of, here's the references that I need. This is targeting .NET 5 and we're building Blazor Web Assembly. Okay. I have a program CS file here that says, well, here's how you bootstrap and start this thing up. We need a WebAssembly host builder. We have an application tag that is identified with this ID inside my application. We have an HTTP client, right? Because we want to be able to fetch resources from other web servers, from other services hosted out there on the web, and go ahead and run that application. Okay, that's something. There's a www root folder here. Let's take a look at that. Inside of here are the static files that are needed to run an application. Those static files that are served out to the web that are things like, well, an icon file or CSS. And this HTML file is the start of my website. Looks pretty typical, looks like something I would see. Doc tape HTML, HTML header stuff, references to CSS. And I have this, there it is, div ID equals app. And that program file said, well, we're going to add into our builder, we're going to define that our application runs at the app ID, like that, hashtag app. Well, it's going to stick my Blazor application right there between those two div tags. And that kind of feels like something I would see in Angular or React or Vue. Put the contents of these components right there between those tags. Now, my components, the contents of my application, are defined by this app razor file. And it defines a router. We're used to seeing routers in some other frameworks that specifies, well, here's how you get around the application. We have some route data. We have a default layout called main layout that we're going to use. And we're going to go and try and find pages that match our routing requirements. So I have inside of, I have pages and I have shared. There's my main layout. Here's the layout that we're going to apply inside of that div tag. I'm going to create a div with a class called page with a navigation menu on the side, a main area next to this that has a link to blazor.net on the top with an about link, and the body of my application is going to appear over here. The actual contents of this body are defined by each one of these pages. So I have a page directive that says I'm listening on the root of the website. Let me see if I can zoom in there. I'm listening on the root of the website, and I'm going to output this content. And I have other pages here that listen on the counter page, and it's going to output this content. And I have a fetch data page here that outputs this content. Now, when I was looking at index, there's this survey prompt thing here. That doesn't look like a normal HTML5 tag that I'm used to seeing. Well, this is a reference to another component. Components in Blazor are defined with a .razor extension like you see here. And whatever the name of that file is becomes our tag name that we can reference and use inside of our application. So this survey prompt with a title attribute being passed in, I can take a look here, and this is my survey prompt with some HTML being output here. And I have these code blocks like you see here. And this is where our C#, our .NET code is that's being executed. So inside of here, if you're used to C#, you're used to seeing things like this. It's a property, and we have a little parameter attribute decorating it that says this is a parameter that you can use on this component. So we have back on, wrong page, we have back on the index, we have the title attribute being defined here. This is being passed in to the title parameter here. And I can use that then inside of my component. And you can see if you look up here, just like in our razor in our Razor markup that we use for MVC and Razor pages, I can reference my elements and my interactions inside the code block by specifying this name after an @ sign, and it'll take whatever's inside this property and output it there on line 3. Okay, that's fine. That's a nice simple demo. And if I go back over here, right, I can run this, right? If I go into my Codegen application, I can .NET run, and it'll run this at the command line, and I have an application that I can go and navigate to in just a second. There it is. So let me open that up. Localhost 5001. It's mixed up. There we go. So there's my application. I've got a nice little sidebar. I've got that content over here. I've got my link to blazor.net, and you see it there. I've got a little counter here that I can click, and it increments, and this fetch data bit here that goes and gets data from a server and paints it on the screen. I'll leave it up to you to navigate through and take a look at more of how this works and how that demo is. But let's say you want to step up and do just a little bit more with your application. Right? If you want to take a look at our workshop that we have available out there, this is the Blazing Pizza demonstration that we have available. And I'll start this up, and you'll be able to see how we have a client application built in Blazor Web Assembly. We have a server-side application that's built with ASP.NET Core so that it can render contents and show different things. And I've got a little pizza store that's been defined and is available for me. This is typical of some sort of a storefront application that you might create. I'd like a pepperoni pizza here. Let's add some fresh tomatoes to that. Add some bell peppers. Let me add some Canadian bacon. Is there ham here? I'd like ham. No, a little extra cheese. I'd like a larger pizza, and I can place that order. And this is all code running in the browser. It's only made requests to the browser to get to the server to get data about the various pizza specials that are available. And you can see here, it went to go get the topping list that was available for me to put on the pizzas, because maybe they run out of some of the toppings. We need to go and get those toppings from the server each time, just to make sure that there's enough in the kitchen before it's ordered. And I can do these interactions, and this is a great workshop that walks through all the things here, including security, interactions with the server that you can find out there on GitHub. You can walk through and learn. I have a video or two here on YouTube that you can check out that walks through this, answers folks' questions along the way, and talks through all the parts of this workshop if you're interested in learning more about Blazor. All right, let me head back over to the slides, and let's talk about components. So we saw that survey prompt component. How's that used? How do we create that? How do we do more with that? Well, in Blazor, every Blazor page is also a component identified by its file name. So I can actually nest pages inside of pages. A page has that page directive at the top that indicates it should be the response for a given folder location on a web request. And you saw we passed information into the component by using a parameter, but we also have this option of cascading values and cascading parameters. So we can specify somewhere up at the top of our hierarchy, pass this value into every child component in the entire application hierarchy, and they can pick that off as need be if they need to interact with it. So something perhaps the user that is logged into the application, you can pass that around by making it a cascading parameter that is passed into every page from somewhere up at the top of the hierarchy of the interactions with the application. We can also use dependency injection. That's a typical design pattern that folks like to use. You can inject and use dependency injection to pass objects into, to pass references, different patterns that you want to use to build your application. You can use dependency injection to inject and make things available inside of your components to work with and collaborate with the rest of the Blazor application. I want to show you a project that I've been working on called the Blazor Web Forms components. These are controls that behave like that old school ASP.NET Web Forms components. Right? You've seen them like this ASP::component. But these are actually Blazor components. More about these and this project you can find at github.com, Fritz and Friends /Blazor Web Forms components. Let me go over to that browser and let's take a look at what's involved with that content. Now I have it in, it's over here. Blazor Web Forms components. Check this out. So we've been building components and we can ship components inside of a library. And we have them right here. You can take a look at. There is a project file. And this project file is a little bit different because this is returning Razor. This is returning a library that's going to be compiled up with NuGet. And you can see there all the package information that's going to be packaged and make this available so folks can reference this like another series of components that they can add into their application. Now, when we build and work with components like this, I can actually deliver individual components that do very simple things. So here's a button component that we can take a look at, and this is just going to output a button tag. But it has the same attributes, the same format, the same capabilities as the old Web Forms application. It has a calculated button type. It has on client click, has styles information that it's passing around, a tool tip that we're going to see painted on our buttons. Let me go down, let me find one that's really complex, like a list view. Right? So if I go down here, I have a list view component, and a list view now has a template that we're going to pass around. So maybe there's templates that we're going to bring in here, and we're going to interact and go through these, and we're going to have some data binding that happens inside of our components. Now that's interesting. And for each item that's inside of that data bound list, that collection of objects we want to represent inside this list view, we're going to do a for each and output those items appropriately using whatever template is specified to my component, and we'll separate them if there's a separator template. So you're showing me some code here. What's this actually look like? We have a live website over here that you can go to that's not styled very well, to be frank, but I can go through and I can see here's those components working. Here they are doing the things that we said they would do. And they look and feel like typical components. Right? It looks like a regular web user interface, but this is running inside the browser. And if I go back here, we can actually see the samples that are being built for that, and we can take a look and open this up, and I can see, well, wait a sec, there's no contents here. So what's happening with this, right? If I go and I show you, here's the list view over here, and there's the contents where it's got a list view component, and it's got an alternating item template so it can make things dark or light appropriately, right? And all of the item data binding appropriately. Okay, that makes sense. I'm following you now, Fritz. But why isn't there any content in the client-side version? I mentioned Blazor works on the server or the client. So all the contents for the demos are here in this Blazor server-side folder, but it also works client-side. I have this project file set up where it actually says, go include all of the contents from the server-side application. The exact same demos, include, reference them, and publish them as WebAssembly demos that work and run in the browser. So I have the same components, I have the same pages, I have the same data interaction, and it runs server-side or client-side, no code change needed. It all compiles and runs the same way. Now that's pretty cool. That means that I can build and deploy my components, I can build and deploy my pages, and not have too much of a concern about where exactly it's going to run. I can leave that up to the actual project that those things are being merged into later. All right, I'm feeling it. That's pretty cool. That's something that I can get my arms around and I can be productive. share that with my team, and push content where I need it to be. All right. But hosting is flexible. We've seen now our applications hosted with ASP.NET Core. You saw I also had static content where it was hosted just through an HTML page. If you choose to use ASP.NET Core as a server-side hosting tool, well, you can have that WebAssembly application hosted on the web server with your RESTful services, all in the same runtime, and handling your HTTP traffic. You can also now pre-render the content from your Blazor Web Assembly application, pre-render it on the server, deliver it to visitors, so you prime the pump effectively. You give them their first render of the application while the rest of the content is being downloaded. It creates the concept, it creates the perception that your application is loading and running faster. Whereas if you use a static configuration here, well, the HTML and all the DLLs, all the things to run your application in the browser with Blazor Web Assembly, they take a little bit to download. But once they're downloaded, it never goes back to the server again. The browser works independently of the server. Well, wait a sec. That sounds like a single-page application. That sounds like something that folks who've been doing Angular and React and Vue have been doing for years and years. And we can do that now with Blazor. All right, let's talk more about that. Because there's such thing as Azure static websites. So what if we hosted our Blazor application just like a single-page application, delivered all that content statically? We could then use serverless Azure functions to interact with some of our Azure resources. Go connect to that database, connect out to our queues and storage locations, interact with cognitive services, and do some machine learning interactions on our data and present some of the findings from them back to our Blazor application. And how about this one? What if we could deploy our application using GitHub Actions on every push to the main branch? All right, that's compelling. I don't like setting up continuous integration all the time. This is pretty cool. Azure Functions, I like not having to worry about managing a server out there. Azure Functions are serverless. That means I only have to write a little bit of a C# function or a function in whatever programming language you would like, and Azure manages the executions of that, and I only get charged each time they're executed. And it's a very, very small cost. You only get charged once you start seeing tens of thousands of requests. Do you actually see it start appearing on your invoice? All right. And if I don't have any other executions running, it's just serving the application content, this gets kind of compelling. Let's talk about that. Let's dig in a little bit to Blazor static websites. So Blazor plus single-page applications plus Azure Functions equals inexpensive and amazing cloud applications. Let's take a look at what this means. So I'm going to go back over here to my browser, and I'm going to show you a Blazor static website that I've been working on for a little bit called ClipTalk. Here it is. So this is an application that goes and fetches Twitch clips and presents them in a social media-like application here live in the browser. This is all easy stuff for folks to interact with that is delivered quickly, is delivered and runs in its own sandbox live in the browser, and it lets you play videos and search around and find other videos that you want to take a look at and show them here. Now, because it's running on Azure Functions, sometimes the functions go to sleep and it takes an extra second or two for things to get started. But these all load up and present in the browser, and I can start watching some of this just by clicking in, and it plays a video from, here's our friends from Progress Software on their Code It Live channel. Okay. That's pretty cool. That's neat. How do I do this? How do I get started with a Blazor static website so that I can deploy a Blazor application and only have functions running out there on Azure? So there's a tutorial that's available out here, and I will copy this tutorial link and share it with you because this is where things are starting. This is still an experiment that folks are working through. There's a link to the documentation. You need a GitHub account and you need an Azure account in order to do this. So let's do it. Let's head over. There's a template that it links to here. And you see we're going to end up with the exact same templated application out here. There is right here, a link to go and generate your application. So I'm going to go over here. I've already clicked through to the generate, and it's going to create it inside my C# Fritz organization on GitHub. And let's call this test Codegen 2021 is what I'll call this repository. I'll make this public. It's going to include all branches. Go. It's going to create this from the template and drop it down on my GitHub so that I can interact with this. So here it is. It's available and we can start building with it, but I want it to deploy to Azure. I want to make this a thing that deploys out there, and it doesn't have that .github folder yet that indicates there's GitHub Actions available to run. The next step is really easy. I'm going to go over to my Azure portal here. I'm going to create a resource, and I'm going to choose to build a static web app, and I'll click create. This is preview, so this is free for you to interact with now. I'm going to drop this down and choose a resource group to connect to, and let's call this, I call this test Codegen 2021. I'm going to put this in East US 2. You know what? No, let's put this in West Europe is the other region I have available. Sign in with GitHub, and my GitHub box popped up over here with a big authorize. Right, let me connect and interact with your GitHub configuration. I okayed that, and now it'll show me, well, go and tell me, well, where's the project you want me to deploy here? So I'm going to reach into my C# Fritz organization, and I'm going to scroll down here and go find that test Codegen 2021. And there's only one branch. It's the main branch we're going to deploy. So review and create, and it's going to validate and drop some content into my project here that will allow us to be able to deploy. So I'll tell it, go ahead and create that. And it's now allocating the web server over here, but in GitHub, it added a workflow. Let me go in here. There's a small change that needs to be made to this because the templates have been updated. The actual base application has been updated here. So I need to change this so that this is client, this is API, and this is root. I will commit that. And with every commit that you make, it starts a GitHub action. So there's the first one that it was running. That one's not correct. But this is the GitHub action for the commit that I just made, pressing save here inside the browser. I'll open that up, and you'll see it's downloading all the .NET things that it needs, and it's setting up .NET out there on GitHub servers. I didn't have to pay for this. This is a free website. This is a public free repository I'm interacting with, and I'm deploying to a free preview service on Azure. So none of this is going to cost me a thing. I'm able to interact with these quickly and easily here. So it's done pulling in all the .NET framework things that it needs. We're going to see down here, well, maybe it said pull complete. I guess it's not quite complete yet. There we go. So it's setting up the entry point for this image here to build the static app client. There you go. We're going to see, here it is. So entry point, and now it's actually going and it's going to start doing its .NET compile. So it found .NET 3.1. So it's setting up and making sure that it can run the .NET command line, just like we did a few minutes ago. Here's the client project. The client project is the Blazor Web Assembly application, and it's going to set up compile. Look, it's got Blazor output right here. All right. And we're going to see in just a second, it's going to compile the Azure functions, and it's going to deploy those. Now, the Azure functions sit in a similar folder called API. There it is, API. It's going to build those and ship those, make those available on the same web server as the static application. And here it comes. There we go. Manifest file created. Now it's getting ready. It's zipped up the API. It's zipped up the app, the Blazor application, and now it's deploying. Here we go. So in progress, it's going to poll every 15 seconds here, and we'll get an update indicating that it's the status of the server as it prepares to deploy and run out there. So 15 seconds later, still in progress. It's still waiting to start this up. We'll give it another 15 seconds and it should be ready to go. These typically take 30 seconds to deploy. But I didn't have to write any of this. How many times have you written continuous integration scripts so that you can compile and deploy to a test area, and you end up with how many commits into source control and say, oh, trying this little change, oh, trying one more change, I didn't quite get it right that time, maybe it's fixed this time, and you end up dozens of changes later and you finally have it working just right. This is built right from the get-go. It's all built, it's all deployed. I can go back to my Azure portal here. I'll go through to the resource and I'll click that URL. It opens in a new browser, and there's my Blazor application running live from Azure. You can go out, you're welcome to navigate to this application. I'll share the link there in chat, and this is running in the browser. It's getting data from an Azure server. You can take a look here, refresh, and see exactly what it's downloading and put into your browser so that it can interact with this website. Once the .NET content is downloaded, look at that. It only downloaded, it wanted to get 311K, but some of this stuff is already cached, so it only brought in 1K. I was able to navigate, right? Even if I do a hard refresh on this, right? It brought in about 100K, some of the CSS, some of the JavaScript that it's loading, but I'm clicking around and it feels native. And this is all running in the browser, being delivered from that web server. Let me show you real quick what the code base looks like. I mentioned there's 3 folders. API, these are where our Azure functions live, and there's the function that's delivering the weather forecast. And this looks just like an Azure function. For those of you familiar with using C# to build Azure functions, it's a little serverless block of code here that's responding to an HTTP request, to a web request. It's going to listen for a GET, and it's going to return just some fake weather data that it's just randomly putting together. So that's pretty easy to understand. And the other half of this is the client application. This is the Web Assembly application. It's right here, client CS proj, and you see this is actually building a slightly older version of WebAssembly. This is the original version that was shipped 3.2.1. There's now a .NET 5 version that's available, but this builds and runs and deploys that static application into the browser. Just like we saw earlier, www.root, there's an index.html, right? There's that app tag that all of our content is going to be put inside of when this compiles, builds, and deploys. So we've got a nice application here that we can build and work with and deploy out to Azure quickly. Now, the other thing that typically happens is when folks give me a pull request, I've got to review it. I've got to make sure that they didn't break anything. So what if I go through here and let's go into the pages of this. I'm going to go into the index page and I'm going to change this. Let's put together a change here. I'm going to go through and change this from hello world to say hello Codegen 2021 in Verona. All right, and I'm going to come down here. I don't want to commit to the main branch. Let's put this in a new branch. Sure, we'll call it patch 1, and we'll just say change greeting. Now, I'm going to click propose changes, and what this does, it creates a pull request. We're familiar with this. This is normal GitHub interaction, suggesting a change, but look at this. It's going to run my GitHub Actions. It's going to build this application, and it's going to deploy it into a staging slot for me. Now, what's that mean? What's a staging slot? Well, just like you might have inside of your organization for your quality assurance teams, for your folks that are testing your application, a staging slot is an environment that's isolated that runs out on Azure in the scope of the same application that was deployed, that you can stage changes at. So that's what this is going to do. It's going to put this application, it's going to compile it up, put it into an isolated environment so that we can interact with it. We can touch, click around, and we'll see it live Out on the public web, it'll be on a slightly different domain name, so folks can't just guess it and go navigate to it. But it'll be deployed out there so that my folks who work in my testing department, who verify the quality of my applications, can go and check it out and see it interacting live with all the other Azure resources that we have. Consider setting up another continuous integration, continuous deployment pipeline so that it ships out to a completely different web location. Takes time, and there's fiddling and tinkering you have to do to make sure that those things work properly together. Well, that's built into these templates that you get by default with the Blazor static website templates. That's really cool. Look at this. It's going to finish going through. It's almost done building those Azure functions. It's zipping up, and we're going to see this in about 30, 35, 40 seconds deployed and available on Azure for us to see that that little code change that I made works. It compiled. Great. Compile is always just the first step of verifying that our software still works. We want to make sure that we run tests. We want to make sure that we deploy to some location so we can put human eyes on that change and make sure that it is behaving the way it should. It's great to automate as many things that we can through integration tests and unit tests, but we sometimes want to make sure, lots of times, we want to make sure we get human eyes on these changes to make sure that they do the things that we expected them to do. So there we go, 30 seconds, and there we go. Now look at this. It's got a different domain name. If I go back to my pull request, so this is going to update and show me that it passed, it compiled, it deployed, and I'm even going to get an email that says, oh, we deployed this, it's available for you now. There we go. All checks have passed. It compiled and it deployed, and it put it in this salmon C and some hex set of characters, -1. If you look back over here, this is salmon C, those same hex characters, .azure static web apps, azure static apps.net. Over here, salmon C #-1, that -1 is the pull request number. So these are kind of predictable, and if I control click to open that up, this opens at that other location, and I get my new content. So it's available, it's out there, it runs, and it's inside my application. And I can see the environment over here on my Azure portal. If I go down to my environments, not only do I have my main branch running, and the last time it was deployed was, for me, just a few minutes ago, but it just deployed that change greeting pull request from this branch to that location, and there's my link to go through and update. Last thing I want to show you about this, the best part about this, is when I do decide to go and merge this pull request, confirm that merge, what will automatically happen here for me is there will be a cleanup operation that happens. If I go over to my actions, it's actually running 2 actions right now. It's going to clean up and close that first environment, and it's going to rebuild and redeploy to my other environment automatically. So I'll click in and show you over here. This is doing the close pull request job. We'll see that what it's going to do is it's going to delete. It's going to close out that other environment when this is done. Really great stuff to automate and make it easier for you to build your applications successfully every time. To have this great, easy success pattern to build with Blazor, build with Azure, static functions, static websites and functions, and be successful and have some very good continuous integration and continuous deployment DevOps patterns that are made available to you as part of the template. So if I go back to that test site and I try to refresh, it's no longer available. And if I refresh over here, the staging slot is gone. I merged the pull request. It deleted that. If I go back and take a look, there is my other pull request here. The merge of the pull request. It's still building, deploying, and this will be available on my main site in just a few minutes. So, what's that mean? What's all this add up to? This all adds up to you can be more productive with the Visual Studio tools, with the Azure cloud, building applications that run in the browser that you can deploy and run quickly on every device. And there's so much power in there that's available to you in the browser. Let me wrap up and share some links for you to all these other things that we were talking about. WebAssembly.org, the awesome WebAssembly list where you can find demos like Diablo, like Doom 3 is at github.com. Mbasso/awesome-wasm. Blazor, get your hands on it at blazor.net. And the awesome Blazor repository that has all kinds of great tools and things for getting started with Blazor is at github.com. Adrian Torres/awesome-Blazor, and I shared the link to the template for the Blazor static web apps in chat. Thank you so much, everybody here at Codegen 2021. I really appreciate you having me as part of the event. I appreciate the opportunity to chat with you about building your applications going forward in 2021 with WebAssembly and Blazor and being more productive. Huge thanks to all the folks that helped put together this event. Really appreciate it. Marco Zamana's hanging out back there, helping out and giving me some feedback over here in Teams, making sure that I'm staying on pace. Thank you so much to all of those folks. If you're interested, if you want to see more, maybe you missed a session that you saw earlier today, I want to make sure you know that all the videos from today's event will be available on the CloudGen YouTube channel. Make sure you head over there to YouTube, click the subscribe button, click the bell so you get the notifications when these are uploaded over the next few days. There's a lot of videos, there's a lot of sessions as part of this event. The speakers that were part of this event did a great job putting all those together. I want to make sure that you get a chance to see all their content. The organizers are editing them together and they will make them available over the next few days. You'll see them start popping up on the CloudGen YouTube channel. All right. Big thanks to the folks at CloudGen IT. If there's any questions in chat, I will stick around for a few minutes. Happy to answer those. But I hope you really enjoyed this. I hope you check out Blazor for your next application. And that Salmon Sea, that CloudGen application that I just deployed, it should be ready. There it is. It just finished deploying. And if we go, it's now deployed. And there it is with the updated title. So I'll paste that back in chat. So if you want to go and see it downloading and running in your browser, there it is. All right, friends, I hope you had a great day. I hope you have a great evening, wherever you might be, whether it is in Verona with the CloudGen team or elsewhere in Europe. Maybe you're here in the Americas like I am. I hope you have a great day. I hope you have a fantastic Saturday. And I'll see you around on Twitch, on YouTube, on the Twitters. So you're very welcome there. Emmanuel, good to see you. Let me say hello to some folks here. Andrea, is it Andrea Donne? Thank you so much. Alberto More. Yeah, huge thank you to all the speakers and organizations that supported the event. Danielle Bazare, yes, you're very welcome. I'm glad you enjoyed the presentation, and I hope this is something that makes sense. Is something that you want to use going forward. So I've really been enjoying working with these static websites. So, all right. You can find me on Twitter if you want to ask any questions. Feel free to drop me a line. I am C#Fritz on Twitter, and I'll be happy to respond to you, get you pointed to documentation, or connected with folks that can help you with any questions you might have about getting started. All right. That's it for me. That's it for this stream. I hope you have a great rest of your weekend. Take care.